Welcome to the lecture series on digital image processing. I am Dr. M.K. Vidyalakshmi and today we will be discussing about gray level transformation. So the gray level transformation is also called as intensity transformation or point operation. So it is a spatial operation which is performed on each and every pixel of the input image. So let us consider that f of x comma y is a input pixel. Then the transformation t is applied on that input pixel. Then we get the output pixel as g of x comma y. So this transformation function is called as the point processing. So here generally this point operation is defined as s is equal to t of r. So t is the transformation function. So where r is the pixels of the input image and s is the pixels of the output image. The t is called as transformation function that maps the value of r to the each value of s. So there are different point processing techniques. The list are image negation, which is called as inversion, log transformation, power law or gamma transformation, contrast stretching or normalization, thresholding. It includes binary as well as the adaptive thresholding. So let's discuss about this image negation, which is called as inversion. So in this, each of the pixel of the input image is subtracted from the L minus 1 and it is mapped to the output image. So L represents the total number of gray level present in the image. The conversion formula is S is equal to L minus 1 minus R. So here this L represents the maximum intensity level of the pixel values in the image. And typically this L value is 256. So which represents the pixel values from 0 to 255 in the grayscale. And R represents the original pixel value of the input image before transformation. So we have to take each and every pixel of the input image and subtract it with the value of L minus 1. Say for example, if R is 120 and if L is 256, then S value will be 255 minus 126. So this negation input will be like this. So the input, we are giving an image. So each and every pixel is subtracted from the 255 and then we will be getting the value of the output like this. So here we could see that darker pixel is appearing as lighter pixel and the lighter pixels are appearing darker pixel. So this image negation is mainly useful whenever we need to convert the darker areas to lighter areas and lighter areas to darker areas. A typical example would be an X-ray image. So X-ray image will be looking like an negatives or film negatives are all examples for this image negation. Next is the log transformation. This log transformation we have two types, log transformation and inverse log transformation. So in the log transformation, each of the pixel value is replaced with its log value. Whereas in the inverse log transformation, we find the inverse of the log transformation of each of the input pixel. So the log transformation, the transformation function is given as S is equal to C log of R plus 1. Here this R represents the pixel of the input image and S represents the pixel of the output image. So the transformation function is C into log of 1 R plus 1. So here we consider this R plus 1 because if the value of R is 0, then this log value will be undefined. So in order to avoid that one, so we take the addition of 1 to avoid the log 0 values. And C is called as a constant which is multiplied to get the transformation. So here this log transformation expands the dark pixel values, that is low intensities, while compressing the dynamic range of the bright pixel values, high intensity values. It expands the dark value and compresses the bright value of the images. So it enhances the details in the dark region. So this log transformation is basically useful for enhancing the details in the dark regions. So the transformation curve appears similar to the log transformation since it is the function of log. So here the input pixel, if you take the pixel values of the input in the x-axis, then the corresponding transformation will be on the curve like this log curve. Next is the inverse log transformation. Inverse log transformation is opposite to that of the log transformation. Log transformation curve is on the upper side, whereas the inverse log transformation, it is just the opposite. So we can directly map the inverse for this each and every values of this log. So we will get the curve on the other side of the log curve. So the transformation function goes like this: S is equal to power 10 R star C minus 1. So this means it is the power of 10 power R star C. 10 R star C minus 1. So here R represents the input pixel and the S represents the output pixel and C represents the constant value. So here the inverse log transformation expands the high intensity values and compress the low intensity values. So it will expand the high intensity values and compress the low intensity values. And it enhances the brighter regions of the image while suppressing the darker areas of the image. So log transformation is usually used to brighten the darker images, whereas this one, it will compress the brighter regions into a narrow darker regions. Next is the gamma transformation. So in the gamma transformation, S is equal to C into R power gamma. So here this gamma is a factor which determines this transformation. When gamma value is less than 1, it transforms the darker to brighter images. It converts the darker images into a brighter images. Whereas when gamma value is greater than 1, it converts the brighter images into a darker images. It adjusts the intensity values of an image based on the power function gamma. So it changes the overall brightness or the visibility or the contrast of an image. So the
type of power law transformation of light.
So the advantage of this gamma transformation is the natural look of the images is maintained in this gamma transformation. So it differentiates between the darker tones in a darker image. Next is the contrast stretching. So contrast stretching is used to increase the dynamic range of the gray levels in the image. In an 8-bit system, the image display will contain the maximum of 256 gray levels. The contrast stretching will include all the pixels in the image to be in the range of 0 to 256. So whenever the value of m is, so whenever the pixels are mapped to pixels values are less than m, then this will be assigned to the darker regions, and the pixel values are above the threshold, then it will be mapped to the brighter areas of the image. Next is the thresholding. Thresholding is the technique in which the gray level values of the image is converted either into ones or zeros. So that is, it will convert the grayscale image into a binary image. So all the pixel values below the threshold T will be mapped to 0, and the pixel values which is more than the threshold T, more than or equal to threshold T, will be mapped to 1, which is a higher value. So binary value of the image of the grayscale image will be obtained. So let us take this image. We could see that the black pixels are converted into black itself, and the gray regions are converted to white. So we can get only two parts of this image, which is one is black and another is a white. So this could be understood by means of this histogram. If we see the histogram, so in the histogram, we are plotting the intensity versus the number of pixels. The pattern of this histogram looks like this. So when we fix a threshold T, we can clearly make understand that this before the threshold value, these values will be background, and the above threshold it will be an object. So the threshold is the one which differentiates between the two segments of this histograms. So we can take this as a threshold.